that our next speaker is going to be talking about operators. We've got Sergey Pronin from Percona, who is joining us from Russia. Sergey, what's up?
That is correct. All good, all good. The weather is not so good, but I'm fine, thanks. How are you?
Good, good, good. Very good to see you. I will let you jump right into your talk so we can stay on schedule.
Okie dokie, let me share my screen just a sec. Please let me know once you see it.
Yes.
Okay, is it full screen?
Yes.
Okay, good. So, as Bart told, my name is Sergey Pronin. I'm a technical product manager at Percona, and today I'm going to talk to you about our XtraDB Cluster Operator and some architecture decisions. Usually this talk is like 1 hour, 1.5 long, so I had to pack it tightly. So let's begin. Let's start with the operator itself at the very beginning. So why operators? Percona is known to be a service company which provides support for databases. And suddenly we started our operators journey a couple of years ago. And the reason for that is simple. First of all, it's customer-driven decision where we see a lot of our customers moving their databases to containers, right? And it is kind of historical because it all starts with bare metal servers, then virtual machines appeared, and now containers because businesses want to move faster and deliver code faster to the environments, and everything moving to containers, including databases. So, and when we talk about containers, when you have hundreds or even thousands of containers, you need to manage them, right? And when we talk about management for containers, it usually means orchestrating the containers. And here is where Kubernetes jumps in. And with Kubernetes, you have lots of primitives which allow you to structure your containers and manage them easily without human intervention at all. And the operator makes sense because even you have a management for your container layer, you still don't have a management for your application layer, which means you still need to set up some kind of replication between your containers if you run the database cluster, or you need to make sure that they're resilient and they recover nicely once they all fail at once, right? So operators is just a piece of software that helps you to manage your application within the containers that are managed by Kubernetes. And operators just simplify the deployment and management for you greatly, right? And the fourth bullet here is called Percona DBaaS. It's database as a service. Percona recently released a beta version of its database as a service. It is 100% open source and free. Everyone can use it, install on-prem or on cloud. And in the background, what it does, it uses our operators to deploy the databases on Kubernetes. So it's kind of a strategic investment for us, meaning why we want to go with operators in the first place. So about our operator, Percona XtraDB Cluster is a drop-in replacement for MySQL Enterprise with all the enterprise features. It's open source and it has Galera in the back, and I'll talk about it a bit later. But if we talk about operator itself, it's again free open source. Latest release just recently, 26th of April, which means we developed it a lot, add new features, fix lots of bugs, and community is helping us with that. Thank you all. On top of my head, like these are the features that we have and which are very important for database world. It's easy scaling, meaning you can horizontally and vertically scale your database with the operator. You don't need to do anything manually. And we have smart update because usually it's a pain when you need to update from one minor version to another. And we do it again automatically, not only for the database, but for all the components. Like we have proxies in there, they're going to be updated automatically. And we have backups with point-in-time recovery. And backups is just, you can do a manual backup, you can have a scheduled backups, and everything is managed again through the operator. And point-in-time recovery is quite interesting because in MySQL world, I believe it is the only operator nowadays which has point-in-time recovery capabilities. And on architecture, our view mainly is that we want to use Kubernetes primitives as much as possible in our operator. We don't want to invent the wheel here. And it all starts with the operator running in Kubernetes, where operator is just the pod, is custom resource definitions, which allow you to extend the Kubernetes API. And it's obviously starts with the user. And the user says, hey, I want to create the cluster. And what it means, actually, the user submits the manifest, the Kubernetes API, which is a set of directions like, do I want a proxy? How big is my cluster? How big is the storage? How big is everything? And throws it at Kubernetes API. And then operator sees the custom resource being created and provisions everything else, like stateful sets for PXC and proxies. Stateful sets are backed up by persistent volume claims. We also do create service object in Kubernetes. If you need to expose your database to the outside world, it can be a load balancer, it can be anything else. So again, we try to use Kubernetes primitives where possible, not to invent anything new here. And it simplifies our solution a lot and simplifies the development for us a lot as well. So let's jump to some interesting technical decisions that we made when we developed the operator. So first, it all starts with the question, why Percona XtraDB cluster, right? Because it's Percona XtraDB, as I mentioned earlier, is the Galera plus MySQL in the background, right? So Galera provides a multi-master solution for MySQL with synchronous replication, and it is highly available by default, by design. And in Percona, we have two products, XtraDB cluster and Percona server for MySQL. And it was the decision that we need to make. Okay, do we want to have build the operator for first one or for the second one? And as long as PXC already has all the capabilities for high availability, because it uses Galera, and we chose that. And then we thought, okay, PXC comes with synchronous replication. What does it mean for us? It means for us data consistency, because in Kubernetes world, again, the pods come and go. It's very ephemeral and volatile environment where all the nodes can be restarted simultaneously, but then they need to recover again. And we don't want to lose any data. So synchronous replication is a way to go here. Obviously, synchronous replication comes with some performance penalties. It can, but and synchronous replication is not needed for all the applications. There are some applications that can lose some transactions, but we wanted to cover as much ground as possible with this operator, so we picked PXC here. And right now it's pretty robust and the production-ready solution. We have a lot of customers using it, and we really love the feedback that we receive every day. The next problem that we wanted to solve is proxies, right? Because when you have a database cluster where you have 3, 5, or many more nodes, you need to somehow load balance the queries. You need to make sure that once some node goes down, your queries are not lost and you don't have any glitches in the application. And also when you have a cluster, again, with a lot of nodes, you don't want your application to solve the problem of, okay, is this node up? Is this node down? Should I connect to this? Should I connect to that? So we wanted to have some proxy layer in front of the database cluster by design. And sometimes we receive the question, why not just a Kubernetes service for the cluster, right? Because you can have a stateful set, and you can create a service pointing to the stateful set pods, and it will do all the magic for you. It will just kill the connection, modify the endpoint, and you're set. But the problem with there are multiple answers to that, and I believe the two the most important ones is that we need to make sure that writes, they always go to primary node. Even it is a multi-master environment, there are you need to write all your queries to master node, because otherwise you will have certification conflicts which might impact your performance. Well, if you write to this node, to this node, to this node all the time, they need to talk to each other and make sure that everyone is aware that the transaction is committed, because it is synchronous replication. The transaction must be committed on all the nodes simultaneously, right? And another problem is if you want to have some caching layer in front of your database. What if you want to do that with the operator? And we decided, okay, why not? We can do that as well. And the architecture for proxies is that simple again. We rely on Kubernetes service, and it can be a node port, it can be cluster IP, it can be a load balancer, whatever you choose. And then it goes to proxy pods, which are automatically configured by the operator, and they all look at the PXC cluster and they monitor the nodes if they are up or not. And on some decisions, again, we wanted them to be highly available. So that is why we run multiple proxy nodes, not just one. And it is by design. So you don't need to do anything. Operator will deploy multiple proxy nodes from day one. We wanted to have health checks, right? It solves the problem of high availability on the database end, because one database node goes down, you want the traffic to go to another node which is live and healthy. And you also want, in this case, know which node is primary, because I just said that you need to write to primary, better to write to primary, right? And then we started with Proxysql, because whenever you talk about proxying and MySQL in one room, you always speak Proxysql. Proxysql is level 7 proxy, layer 7, which means it looks deep into the queries and it can perform caching, query filtering, and other magic there. But it was the first pass. We rolled out the operator, we released it with Proxysql, we had happy customers, and then suddenly people started complaining, saying, hey, and I cannot see the real IP address of the customer on my database. And I'm used to that, right? Because the customer can run his database on somewhere on-prem or on the cloud, where the database is configured with some grants and audit, and the IP address of the user is essential. So that is when we decided, okay, we need to implement haproxy as well. And haproxy is also an open source, well-known solution for TCP and UDP load balancing. And what it meant for us, that once we added haproxy support with all this nice high availability and health checks capabilities, it also meant that the proxy protocol is available. And proxy protocol can carry the source IP address to the destination, to the database. And now the user can configure the grants and perform audit with CEM or anything else on the database without the need to reconfigure the scripts to use ProxysQL for that. So it is the story with proxies. The next thing, is full crash out recovery. It is a common problem when you talk about the databases with synchronous replication, right? Especially, it can be not only in Kubernetes, it can be anywhere. And in Kubernetes, it's super simple, right? You have the database running 3 nodes, as you see here, the green ones, and all of a sudden, all these ports are restarted simultaneously. I don't know what happened, like Kubernetes nodes crashed, the user performed kubectl delete, and one by one deleted the nodes. It can happen. Network partition happened. And what happens then is all these nodes, they go up again, PXC pods go up, and then they look at each other and they don't know who has the latest data, because it is synchronous replication and they don't know, okay, what if I was the latest to fail and some query is there? I don't want to lose anything, right? And again, this is the problem with synchronous replication mostly. And the way we solved that is we decided to add some logic into the operator to make sure we understand what's happening in the cluster. So first of all, we have a PXC entry point sh script, which is the entry point for our PXC container. And it detects if there is a full cluster crash. The way it detects it is it looks for some specific file that is written on the local storage of the node on PVC. And then it checks if the primary is up and running. Obviously, the primary is not there because all 3 nodes are down. And it says, okay, I'm in full crash now. I don't want to do anything. I'll wait for primary when it goes up. Then operator sees this situation and says, okay, something is wrong. The cluster is down. It looks like full crash for me. The operator goes to each and every node and finds the latest global transaction ID. Global transaction ID is the way to track the transaction in MySQL, but this transaction ID is not unique to the specific node, like with binary logs, but it is unique for the whole cluster, which means that once you write something into the cluster, you have some ID of the transaction, and it is propagated to each and every node. Doesn't matter if this is a new node, an old node. So the ID is the same on each and every node. So the operator finds the node with the latest ID. It goes into the logs of PXC pods. Once it finds it, he says, okay, now you are the master, and shoots the PXC entry point script with user1 signal. And this node is now running primary. And then, as I mentioned, other PXC nodes are running in the loop, and they're waiting for primary to come up. And once they see that the PXC has the primary now, we know that this node is with the latest GTID, which means no transactions lost. The MySQL D process starts. Right. So again, it's very common in a Kubernetes environment that all your nodes go down simultaneously, right? Obviously, with anti-affinity and other solutions, you can prevent that, like to run in multiple availability zones on your Kubernetes cluster. But we saw users deleting the pods. We saw network partitioning on GKE cluster when all the nodes were losing each other. And we decided, okay, we need to think how to prevent that from happening all the time, right? And this solution is very easy. And obviously, without this solution, there was a way to recover from the failure, but it was a manual and cumbersome way. You had to find the latest node with the latest transaction. You had to somehow manually recover it, start as a primary. So it's not the Kubernetes way, right? We want to automate out all the manual burden. And this was the solution that we came up with. Okay, yeah, version service. It's another problem with mainly with Kubernetes, but maybe it can be extended to other environments as well. So once you run the database cluster, you need to figure out, okay, what is the latest supported version of the database for this specific version of the operator? Because operator is a piece of code which introduces or adds some features and functionality in Kubernetes for the database. Like we added point-in-time recovery into our operator, and it supports some specific PXC version, some specific MySQL version. And if you run your operator with point-in-time recovery functionality in some old database version, then this feature will not work, right? And it can be the other way around. Maybe you have thrown away or deprecated or removed some feature in the operator, and you also use some old version of the database. So it can be both ways, and we needed to solve that somehow. Also, the problem here is to automate software version upgrades, right? And when I talk about that, I mean not only the database, like latest MySQL version, but I also think about haproxy. I also think about proxysql version. Is it compatible with this MySQL version? Does it have the latest security fixes in place? And also wanted to simplify operator updates itself, because operator, again, is a piece of code. You need to update it somehow to add new features. And it's not like obviously you can update the version of the Docker image that you have or container image, but we wanted to have it fully automated. And one of the solutions that comes out right away is to ship some JSON file with the operator, store it somewhere locally, and then the operator will say, okay, if I'm version 170, I can run this and this and this MySQL version, this and this and this proxy SQL version, and so on. But then the question arises, okay, how do I ship this? How do I update this JSON file to the user? Is it that the operator goes and updates it manually, or sometimes periodically from some place, and so on? So there are many solutions how this can be achieved. What we decided to do is to implement the tool which we call version service. And version service is an open source and free to use solution. And right now it's hosted at checkpercona.com. And what it does is basically answers the questions that I raised before, right? Okay, operators goes to version service and says, hey, I'm version 160. Which version of MySQL is the latest recommended for me to use? Or which version is the latest that I can use, like latest and greatest, not recommended yet, but latest and greatest, which is the supported version of proxysql that I can run at this version. And checkpercona.com just answers this question, and then the operator, once the version is received, it updates the cluster in a graceful way. So you don't need to think how to update it. Should I start with this pod? Should I just update it in the stateful set? Operator does it automatically in nice and easy, graceful way. And again, this is an open source solution, and we have customers who host this solution on-prem, and it works pretty good for them. I had actually multiple slides there about point-in-time recovery and other nice features, but this is a concluding slide of my talk. What are the plans for the operator? What we want to do for this PXC operator, pretty soon, it will come, I believe, in a couple of months, is built-in disaster recovery on multi-region deployments, right? There is Kubernetes Federation, but it's not there yet, and I don't know if it's used in production by anyone. So we want to deliver the solution to customers and users to run the PXC cluster on multiple Kubernetes clusters in different regions, one in EU, one in US, for example, and sync the data between them and use one of the clusters for disaster recovery, for example. This is a very requested and frequently requested feature by our users, and we understand why it is important. It's not that easy, but with the latest releases of MySQL, where there is a way to fail over the replication from one node to another, it becomes pretty easy to deliver. But again, it becomes pretty easy for 4.8.0, not for 5.7. But we'll see what we can do about that. Another frequently requested feature is user management through the operator, which means that we see our operator as the tool to provision the infrastructure for the database itself, right? And then we just give out the endpoint, the user connects to it and starts using the database. But it is frequently asked, okay, how can I create the user on the database with some specific grants through the operator, right? Well, we don't know if we want to go that path yet, but we see a lot of users are asking about that, and we understand again why. And creating the user means storing the state somewhere on Kubernetes, and it means creating grants. It means creating maybe tables later on, stored procedures through the operator. And I don't believe we want to go that way, but we can start with users and see how it would work. And there are multiple questions. For example, do we want to have it a bidirectional feature? Like if I already have created the user on MySQL, do I want to somehow backported or create the user on Kubernetes, like as a custom resource, or no. So it's interesting. And the last bullet here, new operator with a sync and group replication. We see that group replication is maturing. And 2 years ago, when we started this operator journey, it was not mature at all, right? And now we see that group replication for synchronous replication is a good solution, and it can be used in production. And our plan here is to create a new operator, or we can call it version 2.0, with regular MySQL, with group replication and async replication. We are probably on the long run, we're going to phase out PXC Operator completely and rely on group replication only for the sake of simplicity, because otherwise we need to rely on Galera. And you can see our public roadmap as an open source company. You can go there, you can see what we're working on right now, what was released recently, what our plans are. You can create new issues, thumb up, thumb them, so we can jump on them right away. Okay, so I guess, thank you. It was tremendous talking to you. If you have any questions, you can find me on Twitter or just drop me an email. I'll be glad to answer that. And Bart can forward me some questions from YouTube channel if there are any.
Will do, for sure. For the sake of time, we do have to move directly on, but operators are a huge topic of a lot of importance for folks in our community. So if folks have questions, we can continue the conversation on Twitter, in our YouTube chat, or directly on Slack. And Sergey is an expert on the subject, so he can definitely help you out with that. Sergey, thank you very much for your time today.
Thank you, Bart. Take care.
Pleasure. All right,
Cheers.
Next up, we've got a dynamic duo with Eric and Alex. Don't worry.